Hey everyone, welcome back to my another reinforcement learning tutorial. So it was quite some time while we didn't see, so I decided to make another tutorial. Well, it was decided before, but I made it just now. So because it's quite hard to do some stuff in reinforcement learning, so right now I'll do a DQN network tutorial. Well, before we were doing this on Carpal, and right now, as you can see, I created a new folder. It is clean for now. I'll add code from my previous tutorial. But actually, what I will do, I will try to teach the model to play card pool on 4 different models. And of course, you will see that I'll use standard DPQ network, prioritized DPQ network, dwelling, and so on. And I'll check how it performs on all these methods. So before that, I'll show you how to adapt code for for Pong from Carpal. So before I had this kind of code for Carpal, and of course I'll use the same code. I'll copy it here, and now I'll call it Pong v0, and of course this, and yeah, it doesn't matter. I'll decide what's the best name to give for it. And let's open with Sublime. Here we have it, and of course, uh, you shouldn't use you should use it only with Keras. Well, I'll write what version I use. So I'm using TensorFlow 1.15 and Keras 2.2.4 because it might not work for you with previous versions, older or newer versions. Well, I'm writing this tutorial only for this version, and maybe later when I'll be learning about, for example, proximal policy optimization method, I'll try to start using TensorFlow 2.0 or 2.1. But before that, I'm just right now working on this version. So what I'll begin with, here. I'll change this to Pong 3.0, and of course we'll start from the beginning to removing some kind of lines or so on. It doesn't matter. So before we had this, I'll remove this. I'll make 32 layers, and here I'll make it for 8, and or I make it for here 8, and here will be 4, here will be 4, 3, 2, 2, 1, 1. Okay, it's quite fine here, and we can move this to the end of code. Will look much cleaner for us. Move this, add this to the end, just like this, and yeah, we will use all these layers. Maybe, well, I'll check this later how it learns, but for now, okay, I'll leave it as it is. We need to change this because it's not a carpal anymore, but actually it doesn't matter. We don't need a name here. And what I'll use for compiling, I'll use mean squared error, and optimizer will be Adam with learning rate of 0.0005. This is only my example. You might choose different learning rate, it doesn't matter, but I'm just trying this one. And let's move to the code here. And anymore, I don't need some kind of lines like these ones. Oh yeah, I don't need this. The seed, I'll remove the seed for this now. Action size, I will use episodes. Yeah, of course, we might use 1000. Memory size 10,000. Well, actually we can increase our memory size, and here I'll use memory size, doesn't matter because I'll make it a little smaller right now, my frames, and epsilon will be the same. I'll remove soft update because you saw that it doesn't add any performance, and of course tau parameter for soft update, we don't need this anymore. I'll use same models file to save it, and of course we'll change our name of our file, path, model name, environment name, okay, and rows, columns. Actually for poll I will use this kind of, and I'll need to add one more, and this will be self update model steps. It is that I will update our second model every 1,000 steps, like that. And I'll actually, I don't need this here, I can remove, and I can add it here. And of course I totally forgot that indentation. I will use stabs, okay, and stop. Okay, state size will be our same, and here before I used it like this, and I'll use it, it will be a little simpler for us, that, and model, it will be everything the same, and we can move to our retarget model. Here I will use another parameter, it is game steps like that. Yeah, I'll need to remove a lot of this code, something like this, and I'll leave it something here. So if game steps are divided by self date model steps equal to 0, we'll use it like that, and then we'll use a turn and model get weights, so everything is fine here. And what I can say, this line slows down the code performance. It's best to find a different way how to perform it. For example, if I convert game steps to string and I'm checking how many zeros, for example, if I have 3 zeros at the end of string game steps, it means it has 1000. Just this way it might work faster because this checking consumes a lot of performance, but it doesn't matter for us. I'll leave it for training it for a night, and I think I can move forward. So anyway, remember it will use the same function as before. By the way, if you're first and viewing this tutorial, this is some kind of continuation from my previous tutorial where I wrote this full code, which I'm right now editing. So you might check my previous tutorial, or it doesn't matter. I anyway gonna upload this to my website and GitHub repository. So anyway, let's move forward. And right now the most work will be done here, probably on the remember function, I mean replay function. For prioritized experience, probably everything will be the same. And here actually I'll add if length of self memory is more than self batch size, then we do a mini batch, else for example we return. So we want to be sure that we are having a mini batch of full size we want. So here I'll write totally new stuff here. I can move this just like that, and here will be a state, and I'll create a numpy array, so it will be zeros, and here is self batch size, and batch size multiplied. Here will be our self state size, and here will be a d type equal to numpy load 32, because here will be our images, and here will be my next state, some kind of equal, and here will be my action, and it will be also numpy 0, so I can copy it, but here I'll remove a little of code, and here will be our d type of integers 32, and what else we have a reward, as you can see, reward, and reward will make it float 32, and what's left is done, so batch size, and here will be a d type of un, just like that, and here we can write it a little simpler, I think. So it will be like that: action, reward, next state, and of course done. That, and we need to add I here because we're doing for loop as before in our mini batch, and this will be equal to mini batch of I. That. So I remove this, and yeah, I think that's it. And here I have one idea that how to make our simple DQN network, standard DQN network, work better is we need to use a target value here instead of target next. So you'll see when I'm training, but I think it should be work much better. We'll see anyway. And yeah, I think that's quite nice. Okay, here I have a mistake, I think, from my previous tutorial, and I'll need to fix it there, and I'll fix it in my code later. It doesn't matter, but here I need to have indexes, and here I need to have a numpy range equal of self batch size and d type equal to numpy integer 32, and absolute errors will be numpy apps, and here I'll use target all of indices, and oh, not the right place, in the indices, and here we'll use action and save root for action. As you can see, here is no for loop. I integrated a numpy array in this kind of way that we don't need a for loop. But for example, we are doing this thing in a batches, the same as we would do in for loop. Simply, this is a faster way. I could also do everything the same here, but actually this kind of simpler to understand, and because this is tutorials for you who don't know many things about NumPy, this is kind of simpler to understand in my opinion. So here is our memory batch date, tree ID, X, and absolute errors. Okay, I think it's fine. And here is state fit, batch size, verbose. Okay, submodel name, save. Yeah, and here, because we are not having the steps but games now, I'll use games here, and of course I'll this so date, and here instead of the network tab here, I don't need soft update anymore. Also DQN network, yeah, I can place a position of this, and I'll add this to name DQN network plus we don't need a soft update plus dwelling greedy, prioritized experience AAA, and of course convolutional neural networks. And I'll add one more thing for our models to understand it better. I'll add a self model name equal to OS path join. And here it will be self save path self environment name, and here as before it will be as DQ network, so on. DQ network, dwelling, greedy, prioritize, and here that G will be high 5. That, and here right now I'll return not a string but actual value, and okay, I need only the last value of it. We have done quite a lot here already, and here, yeah, I'll use image show. It will be quite the same. Yeah, I don't need a cartpole here, so I can use some kind of self environment name that get image. So here I'll add some more modifications also. Will be my frame, and I'll add a render here. So environment render. I'm not sure if everything will work here as I would like it to work, but I hope so. So let's move on. RGB. Well, anyway, it doesn't matter. It would work like that also. So here we used a CVT color, and here we resized it. Size 0, and this one. I'll rewrite this code to a little bit different, and so what I'll do, I'll write a cropping of frames to 80 by 80 size. I kinda done already this, so I kinda remember how to do this. Crop it, and this will be equal to my frame, which I will get. Well, actually, I don't need this. Also, frame, and this will be my frame of. I'll crop top and bottom this kind of way, and now I'll adding this kind of marking divides the whole size by 2. So if this before was 160, it will become 80. Well, actually you can calculate it by yourself. So next I'll use a frame RGB. This will be some kind of trick here. I'll use a NumPy to convert my image to RGB image. So later I'll write in the full code how to convert this with OpenCV. So it will be up to you. If you won't use this specific size, you might use your own size or whatever you want, and you might resize it with OpenCV. But I will write my way how I'm doing this with NumPy. So 0.99. This will be my airframe. So multiplied by frame, crop it, and add this. Like this. And next I will careless add here some stuff. And here I'll use 587, and here will be 114. And here I use green to frames, frame RGB world. So as I'm now have it converted, next what I'm doing is I need to get a new frame. So new frame, for example, I will write it like this, and numpy array, and here will be a frame RGB, and type numpy float 32, and I will divide this by 255.0. Well, it's kind of same as here, but makes it a little bit faster. And now, yeah, we can keep it here with the same code as it is here. We are placing it here. Let me check 2 more lines here if I wrote everything correct. Well, actually, we'll see when I run the code at the end. Yeah, if we want, we can add more codes here, more frames to see. I'll leave it commented for now, but later maybe we'll try to do something else. So here I need to add a frame as before, and our returning state here, frame. So here is our frame, here is our state. Yeah, everything should be quite fine. We'll see. Oh, here I need to add a frame also, because I added it here. Still need a frame here. So here I'll add a next state. We'll, yeah, it should work like that. And that's it. I think now we can work on this, on a run function. So Pong game has different score function. There is maximum average, and it is equal to be -21. This is kind of score when we lose, and maximum score we can get is +21, but I will show you what is maximum lose value, so it will be our average. So next I can add, instead of I'll add a score equal to 0. While not, I'll add some kind of word here, saving equal to nothing for now. So decide step +1. Here will be act, say decide step. Everything is fine here. Here we don't need anymore reward system. Self remember is the same way. State is equal to next state. Everything is fine here. Score. Instead of I will have a score here, and there's some kind of different reward system. every time we get a 0, and when we have a score we get a 1. Let's see. So if done, here I'm using a different system right now. Average upplot model. Okay, I'll use a score here instead of I as before, and here I write a few more lines. So if average here will be more or equal than our maximum average, I will write that maximum average is equal to average, and here so save it to our self.model name. Next we'll use a saving equal to saving, and else it will be saving equal to nothing. So this is only for our log print function, and so it will be quite the same. Here will be our score, episode. Yeah, we'll use episode. I'll add a F here. Average also be quite similar. Episode, average, and I'll add one more. And here will be our format of E, self episode of score, explore probability, and yeah, explore probability, average, and we would like to see what is our saving status. Yeah, this kind of way, and I think that's it. Here we can use our self save, and we can this and this break we don't need. So if we reach our maximum, oh, anyway, we don't need this. This is only for our log way. We are saving our model here. So we only use our replay, and we are using replay at the end of episode. So instead of here, we'll move it to done. So this means that, no, I need to move it back. Sorry for this. And here is our self-update target model. I'll move it also back somewhere here, just like that. And as I said, that our target model will be updated every 1000 steps, and we'll see. Now the last step is to define our test step, and we won't use it for now. I will use it later when I'll have trained models. So for now, I'll just change full line. So here will be my model name I would like to test. Self-load model name will be. It will be quite similar. Here we'll use episode, state, while not done action. Yeah. That self.render. I would like to see how I play here. Instead of I'll use score equal to 0, and here will be my score plus reward, and here will be my, yeah, I can use it for reward here. Done. I can write a score here, not a reward. Yeah, just like that. And at the end of everything, I would like to close my environment. That, and of course I forgot to add this here. Close environment, and I think that's it. Maybe I can try to build this. There should be mistakes in code. I'm almost sure by 100%. I want to try this on CPU. and let's check if I have any mistakes here. Invalid syntax. Yeah, of course. My first mistake is here. Here comes. We'll move on. Move mode prioritize experience replay. Okay, let's move back. Take it with me. What else? Yep, and too many indices for array. Okay, have something wrong here. So let's check it out. So this is quite fine. Oh, here is the mistake. Image frame. So it should be my new frame. Just like that. Let's see. The target model. I need some kind of steps of game I have. It will be here. The DC step. See now? Still I have some kind of errors. Arrange. There's so many mistakes you can do when you write a code, when you are talking. As you can see, my model is right now playing, and we can wait for it to play, for example, I don't know, these two games, and here receives a negative score, loses, and positive if it would win. So for example, right now, yeah, it has a 1, as you can see. And this is how it would work on CPU training. Sorry, where what is gone? And I'll leave it for, I don't know, I need to train, I think, 4 different models here, so I will need to leave it for a night or 2, and I'll need to record a next continuation of this tutorial. And don't worry, I will come back with the results and models for you, which you can test. And as you can see, it works quite slow with CPU. So on CPU, it might take 1 week to train 4 models. And I'm not sure if these hyperparameters are right to them. So you can see that's quite hard to train this on CPU. Let's check how it would work on my GPU. It should be much faster. It's not much faster, but it's faster. And I'll leave it to play. I don't know. We'll see. So anyway, I will train these models and we'll see how they perform later on continuation of this tutorial. So see you on the next part. I'll, of course, it not going to be a next tutorial. Of course, I will do a merge of tutorials. So we'll see. See you later. For now. Hey, welcome back again. So as I said, I trained a few models, as I said. So let's cover them. And it's almost a week. So I go after my first recording, but I'll merge these recordings to one video, but it doesn't matter for you. So I trained 4 models, and you can see it here. So I used all my choices, almost all my choices. So I used double DPQ network dwelling, and I tried to use prioritized experience replay method, and I used batch size of 32, and And yeah, this was my main parameters, and I made 1000 steps every game. And of course, I'll upload this to GitHub and my page, so you could download it, or you can even download models and test them out. So let's check what were my results. At first, let me show you how it works. So this is the one and the simplest model I trained. It's a simple DPQ network. So let's see the graph. Graph is here, and as you can see, I trained it for 1000 steps games, I mean, and it it stopped almost somewhere here, because between -5 and 0 average score per 50 games, it was quite satisfying for me. And as you can see right now, it's playing quite nicely, and average score is close to 0. Sometimes wins, sometimes loses, but yeah, I thought, okay, that's quite nice, comparing that it's the simplest Q network. Let's see how my another model performed. So next, I added a double network. So let's add this one and run it. Now here plays my double DeepQ network, and here is the results of it. I don't know why, but it goes to another screen. And as you can see, it performed even worse. Maximum average game score was -5 compared to the simplest DPQ network. It's quite disappointing. I thought it totally will play better, but as you can see, score chart is chart, and facts showed by themselves. So I thought, okay, everything is fine. I'll just move to a dueling network, and let's see how it performed. So here it is, and here it plays, and let me show you how it performed. As you can see, score is increasing. So here is my dwelling DPQ network, dwelling double DPQ network, I mean, and as you can see, it trained quite nicely and it played quite nicely. I stopped the model here. I saved the best model. I hope it was the best, and it didn't perform as amazing as I thought it will. There's no such a big difference between previous models. Almost everything depends on the random learning. So I thought, okay. And finally, I gave the most chances, and I thought it will totally perform the best. The model I used with prioritized experience replay, because it requires the most CPU power, memory, and so on. So yeah, I thought it totally will be good. So let's see how it performed. As you can see, it gets positive score and it wins. So actually, it's quite nice. So this is the last model I will show you. How it plays. So here it is, and here is the chart of training, how it performed. So chart talks for herself. So as you can see, this is the prioritized experience replay method trained on Pong, and it didn't play better than previous models. It actually was very similar, and it wasn't improving anymore. So as you can see, all four models are somewhere close between 5 and -5, and I can't even get better. So I decided not to waste my time in this, because this is only for a tutorial purpose. I only doing this to learn by myself and teach for you how to use DeepQ learning for various environments, as cardboard or this, for example, where we to train our model from pixels and so on. So as you can see, it wasn't so amazing. So here I decided, okay, it's enough for me to play with DeepQ network. Let's move for more serious stuff. So I decided that I will move to gradient descent. So about that, I will talk in next tutorial, and more and more and more. So till we get our very good model and we'll know how everything works and which is the best and how to adapt each to each game. So thank you all for watching. This was only a tutorial purpose, but of course if you want, you can download my code for GitHub or my page and try it by yourself, train it, use it anywhere you want. It doesn't matter for me. I just made this for, as you can see, for learning purpose. So thank you all for watching. See you in our next tutorial, and like my video, subscribe, share, and see you in our next video. So, see ya.